Good afternoon, class. Here's the first section we want to cover in trigonometric class, section 1, angles and their measurements. As far as OpenStax text is concerned, is 5.1. Let's pay attention to the topic. We are covering section 5.1, angles and their measurements. Then we go through trigonometric functions and then properties of trigonometric functions. The objectives are, Lou, would you read for us, please?
For sure. The objectives are 1. Convert between decimals and degrees, minutes, seconds measures for angles. 2. Find the length of an arc of a circle. 3. Convert from degrees to radians and from radians to degrees. 4. Find the area of a sector of a circle. And 5. Find the linear speed of an object traveling in circular motion.
Excellent. Here's the definitions we want to look at. Vertex. So this is the location of a vertex. Here's a line, continues indefinitely on both sides. Ray, also known as a half line. This is also the initial side. When we look at this case, initial side is along the positive side of the x-axis, counterclockwise, like so. Counterclockwise rotation is the positive angle. Clockwise rotation is the negative angle. This is counterclockwise and therefore positive. When we put the initial side along the x-axis, the angle theta is in standard position. And counterclockwise makes it positive. Here's the vertex where the two rays come together, the rays being initial side and terminal side. This one is also in standard position, but it's a negative angle because it's going clockwise. The rotation is clockwise. So standard position, initial side is along the positive side of the x-axis. Definitions, quadrants and quadrantal angles. So as you look at the rectangular coordinate system, this, where x and y are positive, is quadrant 1. The angle is between 0 to 90 degrees. Quadrant 2, where x is negative, y is positive, angle is between 90 and 180. Here's the third quadrant, between 180 and 270. and this is quadrant 4. So look at this concept of the angle. This makes it 360 degrees. Okay, could the next person read this part for us, please? Milo.
Yep. Quadrantal angles have a terminal side that lies on the x-axis at 0 degrees or 180 degrees, or on the y-axis at 90 degrees and 270 degrees.
Excellent. So 90 degrees, 180 degrees, 270 degrees, a complete revolution gives us 360 degrees, all up. So basically, the angles along the x or y axis, if they end up having their terminal side on those, are considered quadrantal angles. Let's continue with the definition of quadrants: right angle and straight angle. So as you can see here, theta lies in the second quadrant. It is the terminal side that gives us the quadrant. That this one, this would be the positive, this would be the negative. They are equivalent. This is quadrant 4. And since the terminal side is along the y-axis, theta is a quadrantal angle. Again, you don't have to write anything, class. Just everything is given to you. Access the PowerPoint. Now, a complete revolution where the terminal side and initial side are at top of each other creates 360 degrees. Here's the initial side, and the terminal side is along the positive side of y. This is a right angle, or 1/4 of revolution counterclockwise, or 90 degrees, or pi over 2. This is 2 pi radians. Straight angle, 180 degrees. So here's the initial side, is the terminal side. Half of revolution counterclockwise, 180 degrees, or pi radians. All right, so we want triangles, and remember, this is the, in order to put it in standard position, this is the positive side of the x-axis in essence. So you want to make it 45 degrees. This is your initial side, and this is half of that 90 degrees that we showed in the previous page, roughly. Negative 90 degrees. Now from here you go this way, and that gives you negative 90 degrees. $225 degrees. Remember, this is 180. So you continue. Another 45 degrees. It puts us way into the third quadrant, 225 degrees. 405. If you subtract a complete revolution, or because it's larger than that, or multiples of that. In this case, 360 will do the job. Gives us 45 degrees. So in essence, this is going a complete revolution and coming back to this. So that's how we draw angles. We want to convert between decimal and degree, minute, second, measure for it. As we mentioned, counterclockwise revolution, 360 degrees. I want you to know 1 degree, this is the notation for degree. 1 degree is 60 minutes. 1 minute is 60 seconds. Okay, 1 prime means minutes, means seconds. So this means minutes. This means seconds. Okay. And this means degrees. Let's do this. So the notations. We want to convert 40 degrees, 12 minutes, 5 seconds to a decimal in degrees. And they want us to do the rounding to 4 decimals. So we have 40 degrees plus 12 minutes. That means 12 times 1/60 plus 5 seconds. That means 5 times 1/360. So 1 minute, 1/60 degrees. 1 second, 1/60 times 1/60. So that being the case, 40 doesn't change. 12, because it's in minutes, times 1/60. 5, because it's in seconds, times 1/60, 1/60, or 1/3600. You put this into a calculator. This is the same. This is 0.2. This is this number. Roughly, we want 4 decimals. That's our answer. So this is the conversion method. We want to go back from this decimal part, 78.562 degrees, to the DMS, degrees, minutes, seconds format. And when we go that route, normally we go to the nearest seconds. So this is 78 degrees plus 0.562 degrees. So this portion I can multiply by 60 to change it to minutes. So this portion, the decimal portion, I multiplied by that. When I do the math, it gives me 33.72 minutes. This is fine. This one is point. So I use this one here. Okay. Now I'm going to use this one to go from minutes to seconds. How? I'm going to multiply this by 60. So first of all, this is 2. Okay. So this portion, I'm going to multiply it by 60 seconds because 1 minute is 60 seconds. And we get this. Since they said to the nearest second, number 3 next to it is 2, it doesn't change. So we have 78 degrees, 33 minutes, 43 seconds. William, would you read for us, please? Okay. William, can you hear me?
Yes, I can.
Could you read, please?
Yeah. Radian definition. The measure of a central angle subtending an arc equal in length to the radius equal to 57.3 degrees equals 180 over pi.
Perfect. That is the definition of a radians. Okay. In other words, if you look at this circle, which doesn't have the same radius as this one, but this arc length is equal to the radius. This one the same thing, this one the same thing. That is the definition of radian, and therefore when we calculate it, 1 radian is roughly, it's close to 60 degrees, 57.3 degrees. So to find the length of an arc, we remember the circumference is 2 pi r. So could you read this, please? Arc length is the length of the arc of a portion of a circle, part of the total circumference of a circle. Given a central angle theta, S equals R theta. Here's the idea. When you compare the angles, understand C equals 2 pi R. 2 pi radians represents the arc or angle, and you can represent it with theta. Therefore, S becomes R times theta. In the case of a circumference of a circle, what is theta equal to? 2 pi. So find the length of the arc of a circle of radius 4 meters subtended by a central angle of 0.5 radians. And by the way, the units must be radians for this to work. So S equals R theta. We're going to use that. R is 4, theta is 0.5, and this arc length for this case, 2 meters. As far as the units, the final units are concerned, would be the same units as the radius. Conversion. convert degrees to radians, radians to degrees. So it's a complete revolution. S equals 2 pi r. One revolution is 2 pi radians. 180 degrees is half of the revolution, pi radians. 1 degree is pi over 180 radians. And 1 radian is 1 over 80 pi degrees. One easy way is that replace the degree with whatever you have. Calculate the R. If degrees are given, if the radian is given, replace the R, calculate the D. These are common angles. I believe you know that. Okay. For example, 30 degrees. So if I put 30 here, just as an example. So if I replace this with 30, this is 1/6. So R is 1/6 of pi or pi over 6. These are the common arcs or angles. If you know it, more power to you. If not, you gotta learn it. Okay, they're very straightforward. Everybody. So, for example, 30 degrees pi over 6, 45 degrees pi over 4, 60 pi over 3, 90 pi over 2, so on and so on. Let's do some conversion. And there are two ways to do that. One way is that with one formula, replace, in this case, the D with these numbers and find R. Or since 1 degree is pi over 180, just multiply this by pi over 180. It's your choice, makes no difference. So obviously we know this is pi over 6. This one, 2 pi over 3. This one, negative pi over 3. So those are some common arcs, but what happens when it's 104 degrees? You find the answer in the same manner, but it's not one of those common arcs that we use the pi. So it's approximated, and how many decimals, it depends on how many they ask you to put. Going back from radians to degrees. Now we're going to multiply by its reciprocal, 180 over pi. Because remember, pi is equal to 180 degrees, that's why. Or in this formula, replace the R with minus pi over 2 and do the cross product. Either way makes no difference. Of course, this is negative 90 degrees. Some of you already know it's 150 degrees, but by the way, this is the second method that I mentioned. This pi cancels out this pi, 180 divided, just so you see how easy it goes. So you have 150 and 5 radians is, again, this is an approximation, see, something like that, which is not a common arc, 286.4 degrees. I'm going to assume we don't have any problem with that class, okay? Lou, could you be kind enough to read, please?
You got it. The latitude of a location L is the angle formed by a ray drawn from the center of the Earth to the equator and a ray drawn from the center of the Earth to L.
The purpose of that is to be able to measure this distance using S equals R theta. Please continue with this question. Lou,
Sorry, I didn't unmute myself. Glasgow, Montana is due north of Albuquerque, New Mexico. Find the distance between Glasgow, approximately 48.15 degrees, or 48 degrees and 9 minutes, north latitude, and Albuquerque, approximately 35.083 degrees, or 35 degrees and 5 minutes, north latitude. Assume the Earth's radius is 3,960 miles.
excellent. Please understand whenever you're solving, by the way, this is what they're referring to. Whenever you're solving word problems, you need to write the given. That helps understand the problem better. So first, to have an understanding what we have here, this is with a bigger picture so you have an idea. Okay, so these are the north latitude that they give us, 48.15 degrees versus 35.83 degrees, and we want this distance. That's the idea behind the questionability. So what do we need to know? We need to know the radius, and the radius is given. Theta 1 is 48.15, theta 2 is 35.08 degrees. So the difference between these two angles, because these are the angles with respect to equator, the difference is the angle of interest, the central angle that we want. This angle is the difference between the two. (48.15) minus 35.083. That's the angle. So S equals R theta. You have the R close to 4,000 miles. We have the theta, but we have to write it as radians. So we have to multiply this one by pi over 180. Must be in radians. S equals R theta, the product of this number and this number in miles. And that's the answer. So knowing the latitude will help us calculate the distance between two locations. Find the area of a sector of a circle formed by central angle theta. The formula is half of r squared theta. Here's the reason. And again, the relationship between the two angles is the same as the relationship between the two areas. We know A equals pi r squared for a circle. We know that. So if we replace the pi in the following manner, 1/2 times 2 pi, this can be replaced by theta. So pi r squared or half of 2 pi this. Because remember, for a circle, what is 2 pi? A complete revolution. What if it's not? So just put the theta. If it's not 2 pi, what do you put in? Whatever the angle is. We want to find the area of a sector of a circle of radius 5 feet formed by an angle of 60 degrees. We are going to use this formula. However, we know this is pi over 3 and you must use radians half of r squared theta. This is the precise answer. This is an approximation. When you approximate, you pay attention to the number of decimals. What about this case? Find the area of a sector of a circle of radius 2 feet formed by an angle of 30 degrees. We go with the same formula. Radius is 2. Theta is pi over 6. Theta is pi over 6. Gives you precisely pi over 3, roughly 1.05 units of the radius squared, because you need to use the units of area. Milo, could you read, please?
Find the linear speed of an object traveling in a circular motion. Suppose that an object moves on a circle of radius r at a constant speed. If s is the distance traveled in time t on this circle, then the linear speed v of the object is defined as
Distance over time, as usual, s over t. Please continue.
the angular speed w, the Greek
Omega.
lowercase letter omega, the Greek angular speed omega of this object is the angle
Theta.
theta measured in radians swept out divided by the elapsed time t, that is.
Excellent. So here's what happens, everybody. By definition, linear speed is distance over time. Angular speed is angle over time. So linear speed is s, that's the distance, right? Arc, length, distance divided by t. Angular speed is the theta divided by t. So let's find a relationship between the two. If this is the case, we know s equals r theta. We replace the s with r theta. If we rewrite this in this manner, r times theta over t, this is omega. So v becomes r omega. We proved their relationship. V equals r omega. Okay, could somebody read that? William, could you read this, please?
Example 7. Find the linear speed. A child is spinning a rock at the end of a 3-foot rope at the rate of 160 revolutions per minute, or RPM. Find the linear speed of the rock when it is released in miles per hour.
Perfect. And of course, reminding you of these formulas. 1 mile is 5,280 feet. Omega is theta over T. Okay. And RPM, R stands for the revolution. And you remember a complete revolution is what? 2 pi radians. So that's why omega becomes 2 pi times RPM. I want to make sure everybody understands what's happening. So again, what is given? R is 3 feet. Omega is 160 RPM. We are looking to find the velocity V. First and foremost, we need to multiply this by 2 pi. The reason we do that, because we want it to be in radian per minute. So sometimes we have RPM, sometimes we have RPS, revolution per second, and so forth. And so now V equals R omega. (960 pi), and you change the pi, roughly this is the amount feet per minute. We have the answer, but now we are going to go to basic math, and we need to change this from foot per minute to miles per hour. Okay, so we have the answer, but we don't have the proper units yet. 1 mile is this much. So you put 1 mile over 5,280 feet. Minute, 1 hour is 60 minutes. It's important to know these are unit conversion. What goes at top, what goes at the bottom. This is how you figure it out. See, this one will cancel out this one. This one will cancel out this one. You're left with 21. Put it into a calculator. You have this. So pay attention how you do the conversion. Lou, would you read this, please?
For sure. An object is traveling around a circle with a radius of 8 inches. If in 40 seconds a central angle of 1/3 radian is swept out, what are the linear and angular speeds of the object?
Excellent. So, again, we are doing word problems. So what is given? You read the question. R is 8 inches. In 40 seconds, when T is 40, theta is 1/3 radians. We want omega and V. So basically write the given, translate the question, and use the formula. Omega is theta over T. So what is theta? 1/3 radian. What is T? 40 seconds. Makes it 1 over 120 or 0.008 radians per second. The units of the numerator over the denominator, radians per second. V equals R omega, R times omega. And the reason I use that, it's exact, it's easy. It's 1/15 or about 0.067 units of R per second, R is in inches. These questions are pretty straightforward. We need to understand what's given everybody. The minute hand of a clock is 6 inches long. How far does its tip move in 15 minutes? What is given? R is 6 inches. 15 minutes will help us find theta and then S. So first, understanding the question. R is 6 inches. They said so. When I said that, it's for the minute hand. Over the course of a 15-minute, remember, 15 minutes, you're here. That means 15 divided by 60 revolutions. That means 1/4 of a revolution. 1/4. A revolution is 2 pi. 1/4 of that is pi/2. So when the clock moves 15 minutes, by the way, most of you know that already, but I'm showing you how to get to pi/2. Most of you know it's pi/2. It's 90 degrees. So how do we get the S? R theta, R theta. R is 6, theta is pi/2, precisely 3 pi, roughly 9.42 inches. Same question, 25 minutes. So we go back here and we say theta was 15/60, now it's 25/60 revolution, right? 25 instead of 15, which makes it 5/12 times 2 pi, which makes it 5 pi/6. So it's a different angle, arc. That's all. And again, we go back to this one, and instead of pi/2, we put 5 pi/6. These two cancel each other. 5 pi, roughly 15.71 inches. A 40-inch pendulum swings 20 degrees each second. How far does its tip move each second? What is given? R is 40. Theta is 20 degrees. Because we are interested in 1 second each second, right? S is of interest to us. So please read this question. Make sure you can see they are asking for what? They are asking for S. How far? Okay, so that's the idea. Well, first we need to change this. Can use this formula, replace this one with 20. This is 1/9. And theta, which is 20 degrees, becomes pi/9 radians. S equals r theta. 40 times that. 40 pi/9 is an exact answer. And this is a rough estimate. Units of distance would be units of the radius. Could somebody read this for us? I forgot.
I can-
Anyone, please.
Water sprinkler is to cover a field of 100 square yards in the shape of a sector of a circle of radius of 15 yards. What is the angle needed for this rotation? 2 decimal places.
Excellent. So here's the given. Let's write it out. The area is 100 yards squared. Radius is 15. We are looking to find theta. So again, understanding the problem. Here's the formula. A equals 1/2 r squared theta. Plug in everything. Replace the A. Replace the R. Of course, this is 225 divided by 2 is 112.5. So and this is the exact answer in radians. To change it to degrees, with this formula, replace the R with 8/9. Cross product gives you this answer, roughly 51 degrees, 50.93 degrees. Could somebody read this, please?
A windshield wiper's arm and its blade are 30 inches long. If the blade is 24 inches long and the wiper sweeps about an angle of 125 degrees, how much window area can it clean to 2 decimal places?
Excellent. So we really need to understand the following. This whole thing, arm and blade, is 30 inches. We're going to call it R sub 1. So it covers this entire thing, okay? But we are interested in the windshield because the arm doesn't do anything. And the arm is 6 inches long, okay? R sub 2 actually, it's really that's what it is. Okay, it's 6 inches long. I hope everybody can see why. So what is given? Arm and blade. We call him this entire thing, we're going to call him R1 and it's 30 inches. Arm, only this much. They're telling us it's 6, but it's, if we call it R sub 2, R1 minus 24, which makes it 6. And the angle, 125 degrees. We want the blue area. So when we use this formula with R1, gives us the blue area plus the gray area. So we use R1 to find the entire area. Then we use 6 inches or R2 to find the gray area and subtract from it. So it's half of R1 squared theta minus half of R2 squared theta, where R1 is 30 inches long, the sum of the arm and the blade, and R2 is just this much, okay? I hope it's clear to everybody. So we get 6 inches. It's even given here, it's 6 inches. Theta is 125 degrees. And I'm assuming nobody has any problem changing it to radians. So into this formula goes R1 is 30, R2 is 6, theta is this much, 25 pi over 36. And by the way, use exact answers in all of your intermediate steps. Do the rounding at the ends. That's why I'm going to keep the pi. So half of 30 squared times 25 pi over 6 minus half of 6 squared times 25 pi over 36. Put it into a calculator. 11,250 pi over 36 minus 450 pi over 36, and that gives us 300 pi. Exact answer. Roughly units of area inch squared. A quick recap just to make sure we are in good shape. We are interested in finding the blue area. Using R1, we get the blue area plus the gray area. Their difference is the answer. Go ahead, somebody read this, please.
An object is traveling around a circle of radius 2 meters. It travels 5 meters in 20 seconds. I'm sorry, is that meters or just m?
Yes, meters.
Okay.
Perfect.
It travels 5 meters in 20 seconds. What are the angular and linear speeds?
Excellent. Again, what is given? R is 2 meters. It travels 5 meters. S is 5 meters. Time T, 20 seconds. So write the given, everybody. You want to find the V and omega. V is S over T. Do we have the S? Yes. Do we have the T? Yes. 1/4 meters per second. What about omega? V equals R omega, which makes omega V over R. So this one. divided by r. 1/4 divided by 2, 1/8 of radian per second. Again, very straightforward, everybody. Could somebody read this, please?
A centrifugal force ride, similar to the gravitron, an amusement ride, spins at 22 revolutions per minute. If the diameter of the ride is 12 meters, what is the linear speed of the passengers in kilometers over hours?
Excellent. Again, we are dealing with word problem. What do? Write the given. So we start from the beginning. And this is omega. Omega is 22 RPM. Radius is 12/2 because this is the diameter. Linear speed, V is missing. Never mind in what format, we'll take care of it at the end. But for now, this is the given. Omega is 22 RPM. Remember, we want it to be in radians, and R means a revolution, means 2 pi. So 2 pi times RPM. RPM is 22, becomes 44 pi radians per minute. V equals R omega. R is 6 omega, we have 44 pi. The answer is 264 pi. Meters per minute. We have the answer, but we want it in a different, using a different unit, kilometers per hour. So we are going to write, we want this one with this unit. Is everybody with me? So we have the answer. You want to change the units. Meters, to change it to kilometers. 1 kilometer is 1,000 meters. Minutes, 1 hour is 60 minutes. 1 kilometer is 1,000 meters. 1 hour is 60 minutes. The way you put this, it's important to know that they have to cancel each other in the following manner. This cancels out this one. This cancels out this one. And now you can see what you are left with is kilometers per hour. Now do the math. Gives you the answer. 49.763 kilometers per hour. Okay. Could somebody read this, please?
DVD drive has a maximum speed of 7,200 RPM. If a DVD has a diameter of 12 centimeters, what is its linear speed? What is its linear speed in kilometers per hour of a 0.5 centimeters from the disk center if it is spinning at a rate of 5,400 RPM?
Excellent. All right. So what is given. That's a piece of information we don't need. That is also a piece of information that doesn't come to work for us. The point is located 5 centimeters from the disk center, so the radius of interest is 5. The reason I picked this question because I want you to see two different numbers, but pick the right one. This is fine, but this is what we need because we want the speed at that point. So R is 5. This is the maximum speed, but we are looking at 5,400. So omega is 5,400 RPM. V is missing. So first and foremost, we take care of the omega by, remember it's RPM, we have to multiply it by 2 pi to make it radian. So we multiply by 2 pi, we get 10,800 pi radians per minute. V is R omega. Here's the omega, R is 5. And the units, centimeters per minute. So we have the answer, but we don't have the units. We are going to make a conversion as follows. This is centimeters per minute. We wanted kilometers per hour. So first of all, minute and hour. So 1 hour, 60 minutes. Then centimeters. Remember, 1 meter is 100 centimeters. 1 kilometer is 1,000 meters. 1 meter is 100 centimeters. 1 kilometer is 1,000 meters. And 1 hour is 60 minutes. The way you put them, okay, is such that everything cancels out. Accordingly, this cancels out. So what are we left with? Kilometers per hour. Now you put it into a calculator and it gives you 101.8 kilometers per hour. Please read this one, somebody.
The radius of each wheel of a car is 15 inches. If the wheels are turning at the rate of 3 RPS, how fast is the car moving? Express your answer in inches per second and in miles per hour.
Thanks. So again, you read the question. What is given? R is 15 inches. Omega 3 RPS. V is missing. It's important to translate the question, class. So omega is 2 pi times RPS. So 2 pi times this number. 6 pi radians per second. V equals R omega. So we have to multiply this by R 15 to get the speed, V, linear speed. 90 pi inches per second. And this is an approximation. This is an exact answer. So we have the answer, except we want to make it in this format as far as the unit is concerned. So let's keep the exact answer, 90 pi inches per second. So we have that one, but we want to make it miles per hour. Okay, so think about the conversion we need, knowing that 1 mile is 5,280 feet. Okay, 1 foot, 12 inches. 1 mile, 5,280 feet. 1 hour, 60 times 60, 3,600 seconds. Plug it into a calculator, you get 16.1 miles per hour. Here's the last question we want to do. Please, somebody read.
The mean distance of
The
Earth
mean-
from the
oh.
sorry, go ahead.
No, you can go ahead. Oh, okay then. The mean distance of Earth from the sun is 9.29 times 10 to the power of 7 miles. Assuming that the orbit of the Earth around the sun is circular and that one revolution takes 365 days, find the linear speed of Earth in miles per hour.
Excellent. Thank you both. Thank you so much. So, what is given? We are assuming circle. You know, the orbit is not, it's elliptical, but it's very close to the circle. So, this is the radius. One revolution takes 365 days. Omega is 1 revolution per 365 days. So this is given. Revolution per year. We want to change it to revolution per day, and then change it to revolution per hour. Why do we want to do that? Because it says miles per hour. This is in miles. We are fine. But this one has to be done accordingly. All right. So omega is theta over t. What is theta? A complete revolution. 1 revolution per 365 days. A complete revolution around the sun is 2 pi radians. It doesn't matter the circle is big or small. A complete revolution is 2 pi radians. 1 day is 24 hours. So we can say 2 pi over 365. Notice we put these units, radians per day, and 1 day is 24 hours. So divide 2 pi by 365 times 24, and it becomes radian per hour. And now V equals R omega, everybody. What is R? 9.29 times 10 to the power of 7. You multiply this number by this number, you put it into a calculator, and now everything is ready to give you the proper units. 66,633.324 miles per hour. Fascinating, huh?